So my name is Benoit Queguineur. I work with ALGAIA as a partnership manager, and I've been with ALGAIA from the beginning. So ALGAIA is an ingredient manufacturer from seaweed, and we operate in mainly two markets: the alginate market and also the biostimulant, which are liquid extracts for the agriculture industry. Okay, so there was a bit of a change in the summary there, insofar as I wanted to really present some historical background for industrial use of seaweed in Brittany mainly, and in order to present where we come from and why are we talking about biorefinery at this stage in the history of seaweed uses. So I will present a bit of historic background, but also a biorefinery practical case with ALGAIA setup at the moment, but also show some opportunity that comes with the monitoring of the biomass and knowing the chemistry of your biomass throughout the year. Okay, so maybe just some presentation about ALGAIA quickly. We'll go through maybe the corporate blurb very quickly to present where we come from. Okay, so back in 2016, the ALGAIA was created between the fusion of two companies. Basically, ALGAIA was a mix of Alganact, but also Iagenix. And those two companies were coming from a strong R&D background. Just to give you an example, we had an R&D center before we had a factory. So we first set up an R&D center, and then we had the opportunity to acquire the alginate business from Cargill, which was the largest factory in France and still is at the time. Okay, so the challenges for us were to implement the biorefinery concept. And what we mean by biorefinery is what was Christos mentioned. It's the cascading biorefinery that we are talking about. So the opportunity there when we acquired the business alginate was also to tap into the 40,000 tons of seaweed that are brought to the factory every year. Okay. So some of the first step that we needed to take when we took over the factory was to make sure that we had the distribution network worldwide and that we had the commercial operation set up in order to generate some revenues very quickly. Then the second step was to implement the extraction of biostimulant, which was the second line of extraction at the factory, but also a key step in setting up the biorefinery for ALGAIA. In 2020, there was a new CEO appointed in order to develop and transform and scale up really this biorefinery. And in 2023, we were acquired by the GRS Group in order to transform and really move on in terms of scale. Okay. So just to separate the different phase of development of ALGAIA, first there was the startup phase with the development of revenue stream, which is a very important key step. If you are developing a biorefinery, you always have to keep in mind that you need to generate revenue, and for this you need a champion or a revenue stream. For us, it was the alginate at the beginning, but it could be anything else depending on your setup. And then there was the demonstration phase as we developed the biostimulant extraction line, and then the deployment And as you can see, we went through a number of challenges throughout the year. And I think some of the key successes, relative success for ALGAIA was the ability and the flexibility to manage those challenges throughout the year. Okay. Now, some of the new challenge is the integration within the GRS Group. And just to mention, the GRS Group is a German company that is family-owned, and they have been working with fibers and fibers extracts for a large number of years, and now they have 90 factories throughout the world. Okay, so very large group focusing on cellulose mainly, and they are very strong in the pharma market. Okay. Just to present ALGAIA in brief, we were about 18 million revenue in 2024. We started from 14 million in 2016 when we are roughly about 100 employees. We process about 40,000 tons of seaweed, both from Laminaria hyperborea, digitata, but also Ascophyllum nodosum. And as mentioned, we have a strong foot in the R&D space because we have about 30% of our staff. And in our industry, typically would be more around 4% of the workforce. Okay, so we have about 200 customers, but now it's even more because we have developed with the GRS Group. They have a network, a worldwide distribution network with different business units throughout the world, and sales office also. Okay. So our portfolio is mainly composed of seaweed extract, red seaweed extracts for the carrageenan, that we have a strategic partnership with a Chilean partner as of Gelimar. And for the brown seaweed extract, we have 2 factories now in Brittany extracting alginate. And we have about 70 different types of alginates that we produce in those factories. We also propose specialty seaweed extract. So we talked about the biostimulant line, but more and more we also providing like the cosmetic industry with tailor-made active extract. Okay, so that's the most recent development for ALGAIA, is to provide active extract. And then we also work with our customers hand in hand to provide tailor-made solutions as functional systems. And on the side, we also have another revenue stream in that we open the door of our labs to our customers in order to perform some analytical services or to provide some R&D developments for our customers. Okay. So our markets goes mainly in food, like 80% of the business, the alginate business is done in the food industry. So there was a strong input from the vegan food industry, especially in the US market and North America. But also in meat and seafood, because in meat, you see it in vegetable casing that you see in sausages. Our alginates also find some application in the prepared food and the sauce in order to give a texture, but also in the bakery and dairy industry to have to give some stability and sometimes some gelling capacity to like a napping in the bakery industry. But also for example, in the ice cream business, where you would have it would provide the stability and avoid those ice cream to melt. You also find it in medical device, in wound dressing, but also in dental printing. And you can find it as like as a encapsulation material for yeah for supplements. It is we are also active in the pet food and feed industry, the biostimulant. I think we mentioned it already, but also the soil amendment with some of our side streams. Okay, so the factory is located in Lanillis in Brittany, and it has been operated for the last 60 years. But we will talk about that, and it's a result of a really of the history of the coastal community and the usage of seaweed that moved from the like more the mineral chemistry to organic chemistry, and this factory was set up in the 60s. Okay. Our R&D facilities are based in Normandy, and in there we have all the labs, the analytical labs. We have also have the application lab, and we have some extraction labs, and then we can move on in the scale because we have our pilot scale facilities there where we validate and demonstrate some of the new product development. But we also do some extract for the cosmetic industry because the cosmetic industry requires slightly lower scale compared to the commodity market. So there would be some volumes that we can handle in the R&D facility. Okay. So those are the types of analysis that we can provide. You can get in touch with us if you are interested in some of those analysis. And you can contact Maud Benoit for more in-depth quotation or advisory. Okay. So those are the markets that we operate on: the human health, the food, as we mentioned, the feed and animal health, the plant health, the cosmetic, and also a little bit on the environment. We also have a few applications there. Now, to go through the historical industrial use of macroalgae, focusing more on Brittany. Originally, like basically the first usage of seaweed throughout the world, the first record were dating from 14,000 before Christ in Chile, where some seaweed were found about 25 kilometers away from the sea in some of the prehistorical settlement in Chile, in Monteverde. So those were the first records of seaweed uses. And if you look at throughout the world, some of the most known usage were as a fertilizer for the ground. Some of the land were poorly fertile, and seaweed were bringing some nutrient loads, but also some nitrogen input that were of critical importance for the development of the agriculture in some areas. When we look at the industrial developments, we can look at there are different steps there. So in northern Brittany, it mainly started with soda from the 18th, 19th, and from the 17th to the 18th century. And then the industry moved on to the iodine and snowballed into the alginate, and now more into the fertilizer, biostimulant, and it's now more of a biorefinery setup. Okay. So if we focus on the soda and the industrial development of soda, it started in the ancient Egypt, where they were processing terrestrial plant, and the ash from those terrestrial plant was known as alkali, which you will find in the common terminology in alkaline, for example, in order to describe an alkaline solution or pH. Um, and some interesting fact also comes from the K from potassium. Sometimes it can be an aberration, and people were like would wonder where it comes from. It comes from the Kali from the ancient Egypt. But also the potassium, the etymology comes from the potash, some ash from the pot in German. And basically, what they used to do, they used to burn terrestrial plant in order to provide potash. Um, and like from the 18th century, there was most of the potash was coming from Alicante, from the south of Spain, where it was not based on seaweed. And with the development of the industry or the glass industry in France, they wanted to gain more independence, and so they were looking for sources of potash from seaweed. And basically, at the time, potash was used in the soap industry. But when they tried it with the potash extracted from seaweed, they soon realized it was a very poor quality for the soap, because it would stain the laundry, for example. Or so it was mainly the extraction of potash was mainly used for the glass industry, and especially the bottle industry, because the salts that were present in the seaweed were staining the glass. So hence you had a stained glass that was used for the wine industry. Okay. What you see in the painting there below are the way that it's called kiln, and in Brittany, but not only in Brittany, you would see that basically on the west coast of Europe down to northern Portugal. You would see those seaweed ovens that you would find on the shore, very close to where you would find some beach cast seaweed and dried seaweed. And historically, they laid some big slabs of stones so that they can have some slab of potash that they can use for the glass industry. Okay. This whole industry and this whole potash slabs from seaweed ended at the end of the 18th century, where like a new process applied, a cheaper process applied for the glass industry. Okay, so then you had a coastal community that was relying on those revenue, that was left without revenue, with the strong knowledge of the beach cast and use of the seaweed. And in the beginning of the 18th century, basically Napoleon Bonaparte was trying to spread his authority across Europe. And his army was a great consumer of gunpowder. So the production of gunpowder at the time was limited with the availability of one compound that is called saltpeter. And so they were trying to use the ash in order to crystallize the saltpeter. And so they wanted to replace the ash that was coming from Sweden at the time by some seaweed ash. But when they were doing some trials, they soon discovered some violet fumes from the extraction vessel, like as you can see in the picture there. And That became very intriguing for the chemists at the time, and they soon associated this violet color with antibacterial activity. And there was a large industry that was built on iodine at the time, not only for medical industry as an antibiotic, but also for the development of the photography industry. And iodine is coming from the Greek iodes. Correct me if I'm wrong, but it means violet etymologically. Um, and this was coming from the violet fumes that were discovered. It's an industry that was running from the 19th to the mid 20th centuries, and it stopped in 52 because there was a strong competition from Chile. Even though this was a very successful industry, at least in Brittany, there was a number of factories that were set up. In fact, there was 25 factories that were set up along the coast of Brittany. Okay. So far we've mainly discussed about the mineral uses of seaweed in terms of soda or iodine for the industry. Um, Maybe to mention some volumes. I don't know if I had some figures here. At the end of the First World War, it was estimated about between 100 and 120 tons of iodine at the end of the First World War, which would more or less correspond to 200,000 tons of raw material. Okay. And then when the iodine industry collapsed, another one took over in terms of alginate. So the development of alginate industry really kicked off in the 50s and 60s in France with the development of two factories that are still in operation today. So there is one GRS factory in Landerneau, and there is ALGAIA, which is also owned by GRS and based in Lanillis in northern Brittany. Okay, so with the development of the alginate industries, there was also a large increase in the boating industry, with at the moment there is about 32 different boats with quotas and GPS tracking, but we will talk a little bit more about the resource later on. So basically, just to let you know that the alginate was taking over. And initially, the factory was focusing on one single molecule, which was alginate. Now, with the development of ALGAIA, we have moved to several molecules coming out of the factory and several extracts, sorry, coming out of the factories. Okay. But we'll get more in details later on. Just to give you also some historical examples of a biorefinery. Again, this is linked to the war because back in the First World War, the main potash was coming from mines in Germany, and of course, when the war was declared in 1914, they stopped selling potash to other countries, sorry, because this was coming into the production process of smokeless gunpowder. So at the time, they needed to find an alternative both for potash and acetone. And they found the alternatives in seaweed, and especially in macrocystis in California on the west coast of the US. And between 1913 and 1919, there was about 1.5 million tons fresh weight of kelp harvested. And they developed this biorefinery. Within 6 months, they had the capacity. As you can see, they built some large ship that were able to harvest about 500 tons per 24 hours. Okay. There was about, in the end, at the end of the war, there was about 52 different products that were coming off this this first biorefinery, mainly in order to develop war products. So they at the end of the First World War, there was a strong decline in the industry. And there was a reset as well on the products that were developed, and alginate was also one of the products that came out after the war and not during the war. It was not used during the war. That came only later with the DuPont factory. Okay. And now, when it comes to ALGAIA, I'm going to show you some the biorefinery, or the cascading biorefinery as we see it. Okay, so everything starts with a raw material and need to end with a standardized product with a validated market. Okay. At the moment, we have different streams in our factory. And every time you have a byproduct, you can have some bioactive, some solid byproduct, some liquid byproduct, and we can find some application with those. I'll get more into details there. In our case, we start with brown seaweed. Because we started with an existing factory, the setup was already made, and we didn't start from a blueprint that would be done on a computer. We are actually talking about the practical case of using co-products from the factory and developing a separate line of biostimulant, as you can see here, represented by biosteam, which also comes with different waste. And during the production of alginate, we generate some solid byproducts, which is used as a biofertilizer in the local communities in the surrounding fields from the factory. Okay. Some of the things that you need to keep in mind is that you need a sustainable raw material, and for that you need to put in place the measure to ensure that you have a reliable, constant supply of raw material. And for seaweed, it's very much linked to the seasonality. And we work with about 30 different harvesters, and you have an example of the harvesting boats there, with the technology that was developed in the 60s and 70s in France, with the Scooby-Doo, especially for the harvesting of Laminaria digitata. When we look at the harvesting of Laminaria hyperborea, this is a pluriannual species, so we need to define some rotation plans. And you have an example of the zones in the west of Brittany here, with the green zones, and like there is a rotating plan in place every 3 years, in order to let the biomass regrow, and ensure sustainable harvesting. Okay. We are also working with cultivated biomass, but more on a research and development purpose. Okay. I'll go quickly now through because this is the regulation in France and the way it is set up in order um, to authorize and to get a license for the harvesters. Like ALGAIA doesn't have a license for seaweed harvesting. We buy our seaweed from seaweed harvesters, and they have a license and they need to apply for a license to the local fishery department, which is then deliberated with the commission specialized and dedicated to seaweed in the regional fisheries. Then it moves on to the national fisheries with the advice of Ifremer, with the scientific advice, and then it is approved by some representative of the state locally. Before they have an official approval for their licenses. It's very much regulated. It's quite a heavy regulation, but this is in order to ensure some sustainable management in France. Okay. Those we talked already about. It's the rotating mechanism that are in place every 3 years in West Brittany for Laminaria and Hyperborea. Maybe just to let you know that France is the second largest harvester after Norway in Europe. And the harvesting started back under Louis the 14th in the 16th century, 17th century, sorry. And the harvesting, as we mentioned, requires some license from the state, because as we see it in France, everything below sea level belongs to the state. Everything that is on the shore belongs to the local representative of the state. So you need a license from the state or the local authority in order to harvest the seaweed on the shore or at sea. Okay. This we mentioned already, and this is an example of a contract that we have with our supplier, which are called Queguineur in northern Brittany. In those contracts, we set up of course, a price, a volume. We agree on a volume, and we also agree on the quality of the biomass, even though it is sometimes quite hard to implement, and we will see in a couple of slides. Okay. So now that we've secured the raw material, the next important thing, and we've mentioned that before, is to have a mainstream product that creates some cash. And this is of utmost importance for your business and the sustainability of your business. Okay. When we look at the different market and the positioning for the seaweed products, you have the low value product, which are basically the fertilizer, the platform chemicals that are below 1,000 euro per ton or 1 euro per kilogram. Then you have your liquid biostimulant, but also your hydrocolloids, the likes of alginates, that have a mid-range value between 1 and 10 euros. Like now the price of alginate is slightly higher than that. We are more between, for ourselves, we're more between 20 and 50 euros per kilogram, depending on the application. And then you have the bioactives, the likes of plant biostimulants with like a strong annual growth of over 12% per year. Um, and this is driving the bulk of the profit. And this is really the I would say the low-hanging fruit in terms of revenues for seaweed extracts. Okay. Of course, you have to ensure the technical feasibility of your extraction, and this is where the LCA that were presented by Christos before comes in very handy because it gives you it pinpoints the points in the process where you can improve the technical feasibility and the economical down the line, the economical feasibility. Okay. Um, in order to ensure your economical feasibility, you have to make sure that your product fit the right market price in terms of positioning with the competition. And at the moment, we are experiencing very strong competition from Asia on the alginate market. So when you're facing those kind of strong competition, you have to rethink your client portfolio deeply, and this has some strong implication on the way you deal with your clients. This is a very important part. Um, of course, as was mentioned in the LCA, the capex involved in your production is critical because it will impact also your production costs. And something we haven't mentioned yet is the market share potential and the regulatory freedom to operate. Okay. Something that we'll mention now is the growth potential. And I strongly advise if you're interested in seaweed markets, is this report from the World Bank, and I've included a QR code there if you want to flash it. And in there you will see the different markets for seaweed on the short term, medium term, and longer term. So you can see that on the short term, the biostimulant is basically a safe bet, and then you have the animal feed, pet food. What is coming next is not only nutraceutical, but this is also including the cosmetic industry, not only the nutraceuticals. And then down the line, you will have the alternative proteins, fabrics, bioplastic, even though this is a market that is facing strong competition from the fossil industry, obviously, and that still needs to prove its feasibility and its scalability. Okay, I also included here some interesting tools that you can find on the European platform, which is called EMODNet. And there you will have you can have basically an overview of the seaweed industry and the seaweed biomass in Europe. So that's a very interesting tool. I also included for the one of you that are curious, the number of emerging companies in Europe. That goes up to 2020, but it actually grows exponentially. Okay, so something that is of utmost importance is the regulatory freedom to operate. So you can have all the biorefinery in the world. If you do not have the freedom to operate in those markets, you're not going to be able to sell. So with this comes a very strong certification that needs to be applied in your factory, and depending on the application, the food industry, for example, you have FSCC 22000. You have the FAMI-QS for the feed industry. You have the Cosmos for the cosmetic application. So it's very heavy on the certification. It takes a long time to set up. Like for example, for the cosmetic industry, like it takes about maybe like a year to set up some of the certification, but it's well worth it. Okay, so I'll uh, I'll present you now the more or less the biorefinery setup as we have it. As you can see, we have two production line at the moment. We have the what we call the agri ingredient or the agris, and this is the biostimulant production line. But we have also now the alginate production line. Some of the co-products from the biostimulant line goes straight into the alginate process. And we have also now found some valorization of our liquid waste for the perfumery and cosmetic industry using the volatile compounds from the evaporation waters, which is a very, very interesting and very unusual application. Okay. From the alginate production line, we have both some solid and liquid waste that are in the past it was costing us about 500,000 euros per year to get rid of, and now we have some application in the fertilizer business. Okay. Something that I wanted to mention as well, we were lucky enough to be supported by some European projects in order to develop some of those new applications. The ALGAIA for IBD project, but also CMARC project, the locality, and of course the agriculture, which is this summer school is part of. Okay. And the agriculture is looking at our different waste products in order to develop some base chemicals for fermentation. Okay. So I'm going to show you some example of how the monitoring at the factory and knowing your raw biomass is important in order to find some opportunities in the biorefinery. Just by knowing the biomass and separating some of the different parts of the seaweed. But this is also something that might have been touched or will be touched by some of our colleagues from Alginor. Okay, so you might expect to see something from them around that. What we do at the factory and something that is quite unusual and that takes quite a large amount of hours and workforce is the sampling of the biomass at the factory and separating the biomass between the stipes and the frond and measuring both the stipes and the frond, separating also between you can actually measure the age of the seaweeds and separate between the young or the old seaweed because that also advocates for like longer rotating plan especially for Laminaria hyperborea. We have found that the older the seaweed, the better we would have basically the yields of extraction for alginate, for some specific alginate. Okay. So basically, with what we do, like we collect about 25 kilograms of seaweed, which is representative of 90% of the population. Not 25 kilograms, sorry, 25 individuals, which is representative for about 90% of the population there. If you want to go to 95, you have to collect about 100 individuals, and this is strongly labor intensive and not feasible at our industrial scale. Okay. Regarding the alginate content, we can see that we have a variation between 22 and 26 for Laminaria digitata only. But when we look at the bulk of seaweed that comes into the factory, it's not only Laminaria digitata, you also have some co-harvested species. And those co-harvested species tend to drop the yield for alginate extraction. So there are some strong incentive basically to have, as you can see here, we set up a quality, a minimum requirement of 15% of Laminaria digitata in the loads. But sometimes we get other species and we get some dominant species, the likes of Saccharomyces polyscides, which lowers our extraction. Hence, there is some, as you can see here, the white seaweeds on top of the canopy there. It's Saccharomyces polyscides. So when the Scooby-Doo comes down in the water, it actually would grab Saccharomyces fairly easily compared to other species. So it's also important to rely on the knowledge of the harvesters there. And we can see that the impact is very strong on the process during some periods of the year. If we look at the amount of seaweed that is necessary to extract 1 ton of dry alginic acid, there's a variation of 8 tons of biomass. If we look at there in green, it's only Laminaria digitata, theoretical yields. And if we focus at the mixed kelp coming into the factory, we have about 38 tons that are necessary in order to have the same ton of alginic acid. So this is a strong driver, and it actually pushes us to think about how to or rethink how we can implement a premium for when you have harvesters that can mainly deliver Laminaria digitata. But it is difficult to put into place. I think I need to move on from Laminaria digitata to Laminaria hyperborea. Basically, what we do, we have like 2 species. Laminaria digitata that we mentioned earlier is the summer species, and Laminaria hyperborea is more of a winter species. And you have an early season Laminaria hyperborea. So here you have from March till May, and then we harvest also from September till November Laminaria hyperborea. Then the sea is slightly too rough, so it's not harvested during the season, the heavy stormy season in Brittany. But you can already see that the dry weight content is strongly impacted between the 2 seasons. And this is mainly driven by one compound that is the laminarans, which is a beta-glucan. It's a reserve carbohydrate that the seaweed would accumulate before the winter. And you can see that you have a stronger accumulation of those laminarans. So you have nearly 30% of your fronds that are composed of laminarans. And now those laminarans are prebiotics. They have proven bioactivities both for the biostimulant market, but also for the prebiotic market. So this is this is an example of like knowledge-driven um, opportunity in Laminaria hyperborea. And nowadays we have some extractions that are based solely on the fronds of hyperborea. Okay. Maybe some takeaway messages from the biorefinery as we see it. As we saw, the whole industry moved from more mineral chemistry with the soda, moving on then to the iodine, and then it moved to the alginate industry. And nowadays, with the price of seaweed increasing in the last couple of years, the biorefinery and the cascading biorefinery is nearly mandatory for future industrial development. Not only because the commodity markets have very low margins, so you need to make most of the biomass by using all the co-products in order to be competitive with, for example, our counterparts from Asia. But also it is mandatory, the biorefinery is mandatory where for some biomass, like cultivated biomass, where the cost is still relatively high. And it is also interesting, the cascading refinery, in order to reduce or divide the environmental impact over multiple products, as was mentioned during the previous presentation. For us, it's important that the added value remain local, and we've seen that over the centuries in Brittany. There is a strong knowledge and like a strong community that is linked to the seaweed harvesting, and then something that we want to keep locally as well. And we believe that if biorefinery would be to develop at a larger scale in Europe, it would be through small biorefinery scattered around the biomass resources in Europe. Okay. We also believe that the co-products and innovation are strongly based on your company or your factory and the setup of the factory, and also depend on the local industrial network and ability to find and develop opportunities. Okay. I would like to thank you all for your attention, and especially again, Dr. Nikolodakis and Professor Toutsos for their invitation. If you have any question, do not hesitate to either to contact me by email or to use the chat there. Again, apology for my voice. I hope it was still manageable for you to hear. And I'm looking forward to your question.
Thank you very much, Dr. Benoit. There are two questions in the chat.
Okay.
One's in French.
Okay, I will have a look there. Where is the chat? Sorry there. So I think it's the question about like the boats, if they actually prepare the initial biomass. And the answer is no. Like the seaweeds are harvested in bulk, and it's then in the factories that there is a process of separation and preparation of the biomass. And then for the second question, which species are you cultivating? Like ALGAIA is not per se cultivating seaweed. We rely on cultivated more for R&D development, and also in order to follow closely the development of cultivation in Europe, because we believe this is like there is a strong added value for cultivated seaweed in some areas. And I think this is cultivation only offshore. What we see in Europe, it's mainly Saccharina latissima that is cultivated at large scale at the moment, even though the cultivators are facing some struggles in terms of product development from the seaweed and in order to find an economical model that is viable. So it's mainly offshore, but there are some very strong and very important initiatives as well in Europe in cultivation with the likes of ALGAIA Plus in Portugal, who are relying on the IMTA system. And they basically using all the different trophic levels in order to make use of all the biomass of the food chain, but also the capital resources of the local industry. Okay, so another question was how to deal with the first barrier to seaweed valorization. That would need to be more precise of a question, but maybe the first barrier of seaweed valorization. I don't know if it refers to cultivation. I think I replied on that point. So I think we've covered all the questions. Do not hesitate to contact me directly on my email address if you have more specific questions.
Thank you very much for your lecture and your insights, of course. And
thanks a million for the invitation again.
Yeah. And thank you everyone for attending this stage of the summer school. And we look forward to welcoming you in day 3 on Friday, where we'll continue with more lectures on the biorefineries and conversion pathways.
Thanks a million. Looking forward to.
Thank you, everyone.
Bye now.
Bye.